Today I'm going to attempt to do a multi-channel ADC operation and how I go through the process of doing that. Don't know how it's going to go. I haven't done multi-channel in a long time, so this is a good opportunity for me to show my process, whether it's going to be tripping over my feet or a smooth process. So the resources that I'm thinking of using is my book, so I can cheat a little bit. Probably the data sheet or the programmer's reference or the reference manual for the microcontroller, or if I get completely stumped, I'll just go to Claude or GPT and see what that does or how that helps. So working with the typical microcontroller, the sole chip, not doing anything fancy. I will be using the same sensor. This is the TE830M1 2000G accelerometer. So we have these, well, let me show you the back of this. We have the green, blue, and white, X, Y, and Z, and we have the power here. But first I want to see what I need to do multi-channel. I'll probably go to my book first. I'm thinking I don't know if I have multi-channel in my book or not. I can't actually remember. But I used my book. If you watched my previous video that I dropped last night on ADC, I used the book for the entire process. This is the book I'm talking about. If you don't have one, and if you're interested in microcontrollers, I highly recommend it, obviously, because I wrote it. All right, so let's see. Do I have anything on multi-channel? I don't think I do, actually. Okay, for potentiometer, channel select function, convert function. All right, let's see if I even get into that. I don't think I do. This is not for advanced stuff, so 256. So the channel select function. Okay, huh. Maybe I do go into it. Look at that. So this is the 32-bit number here. I'm putting a 1 in the bit for the channel that I'm wanting to read or to receive. So then I use, let's see, yeah, the channel select register, and let's see, for the channel, yeah, I bring in the channel. So channel 0, channel 1, channel 2, and channel 3. So I'm going to go ahead and open my project, see where I need to do this, see where I can put my windows. So I'm going to be opening this program here. It's the STM Studio STM32 Cube IDE, not the Studio. Okay, so let's see. If you haven't watched the video that I put out, this is just a program to read the X value of the 2000G accelerometer. So what I'm doing in this program is, this is an automatic configuration here, the system clock. The include main has the includes that we need for the particular or the specific microcontroller, the STM32 F030. This is a function prototype. Function prototypes just inform in the C language that you're going to have a function later on in the program, so it knows that it's there, so I can actually use it prior to it knowing the function. So it's all the way down here. This is the system clock configuration, and this is automatically generated. This is nothing that I wrote myself. So when you start up a new program, this is not going to be something you need to adjust unless you really need to have higher speeds or make the what do you call it, the clock faster, or if you need pre-scaling or whatever. But we do get into connecting the clock for the ADC. So I have a variable here. This is a volatile variable, so it doesn't get optimized out when I compile it. And I'm going to change this variable name because it's not right. value, ADC X value, and I use it down here. So now they should be the same. Yeah. So I'm initializing it to 0 before it gets to main. I could probably put it into the main function. I'm wanting this to be a global variable, so it doesn't really matter. I'm keeping it outside of main. The HAL initialization, if I want to use HAL libraries, I can do that if I need to. So it's in here. I don't generally use HAL, but I'm not gonna be using it today either. But I might later in the future. So when I started out, all I did was I wrote down a bunch of comments to tell me what I need to do. So the first comment that I made was initialize the ADC and then get the ADC conversion. So this is kind of like pseudocode, but inside of the code. So first I need to calibrate the ADC. This is probably not something that you need to do, but I do it anyway, and this is what the reference manual tells me I should do, so I do it. So it's calibrating it probably to the reference voltages that are on. That's interesting. Why is it showing this? I will do that then. That's odd. Okay. So the reference voltage is going to come from, most likely. There's also a reference, I think there's a reference voltage pin that you can also use to adjust the reference voltage. But the reference voltage is the span of voltage that you will be using for the ADC. I think if you're not using the reference voltage, it probably uses the voltage here as a reference. And the reference voltage, according to the reference manual, is a band gap reference voltage, which means that it's extremely accurate and it's a stable voltage. So internally with the chip, they have circuitry in the chip, or designed the chip so that that reference voltage is very stable. All right, so I'm really kind of going through this myself in my head, and hopefully it helps you guys, just so I can sort of orient myself with programming. And then the setting the clock, the ADC needs a clock because it has to sample on the clock pulses. So each clock pulse, or I'm not really sure if it's pre-scaled or not, but a sample is taken from the voltage, the output voltage, and it creates a lot of samples per clock cycle, so it can give you a more accurate result. So the more samples that it's able to take from the analog voltage, the better the output will be. But it could also cause problems with the sensor, because the sensor may not give you that much time to sample. So I can imagine a case where the sample from the output of the device or the sensor could be so fast that the ADC might think of it as just a blip or an error. So all of the samples around it could be like 0, but then it gives a very short pulse of voltage. It might not be able to get a good reading from that. So it could be good to increase the speed of this to get a good sample. And by the way, if you guys have any questions, let me know as I... Okay, so this is where I'm connecting the ADC to the HSI 14ON clock source. And once I connect to it, I want to make sure that it's ready. So it's finished connecting to the clock. So I use this while and these masks to determine if it's 1. So it will, well, actually it's when it's 0, actually. When it's 0, it will be ready. While it's 1 or not equal to 0, it will stay in this loop. And when it becomes 0, it'll move on to this next statement. Then I'm doing the configuration. I can't remember what this is, actually. Let me check. Okay, this is a setting for putting it in asynchronous clock mode. Let me see if I can look that up in the data sheet. I probably have to download the data sheet, but Hopefully not. All right, this is a big reference manual. There are 775 pages, but it's relatively easy to navigate. The check modes for the configuration too. So let's take a look at the ADC section. Okay, so the check mode right here. So just by clicking it on the table of contents, I'm there. The ADC has a dual clock domain architecture so that the ADC can be fed with a clock, ADC asynchronous clock, independent from the APB, which is the Advanced Peripheral Bus Clock, PCLK. All right, so here's, I don't really understand block diagrams that much, so I'll take a look at it, see if I can understand it. I think the more I look at block diagrams, I can understand it a little bit better. So we have the analog ADC CK, and you have the RCC reset and clock controller. This is used in almost all of the peripherals. The input clock of the analog ADC can be selected between two different clock sources. Okay, so I'm using the two clock sources, which would be the HSI 14ON, and I guess the other one that I don't know about. So let's go to the check mode here. So it gives me some programming on how to do this, which is what I'm doing right here actually. This is pretty much identical to what I'm doing in my program. So I'm enabling the peripheral clock, the HSI 14 RC oscillator, waiting for the HSI 14 to be ready, and then I'm writing 00 in the check mode, which it has this commented out, but it's because it's 00, it's probably default anyway. So let's go back to where I was. Okay, so this is the actual register here. So we have the check mode right here. So if we, let's see, 00 is the ADC clock. Okay, so asynchronous clock mode generated at product level referred to RCC section. So I'm thinking this is required for just setting up the clock mode for the ADC. And then you have the PCLK divided by 2 synchronous clock mode and the PCLK divided by 4 synchronous clock mode. In all synchronous clock modes, there is no jitter in the delay from a timer trigger to the start of a conversion. The software is allowed to write these bits only when the ADC is disabled. Okay, so that's a good point right here. So the programmer's reference manual, or the reference manual for the chip, is informing you that this needs to be disabled. So when you're writing it, that's why I'm disabling it in the beginning. So this is the AD enable pin or bit, and I'm and notting that, which means that I'm putting a 0 there, so it's not enabled. So once I've done that, I can put it into the ADC CLK mode, and then let's go back to the program. So I've done that. So what I've done is I just put 0 into the 0 bit of the CK mode and a 0 in the 1 bit of the CK mode. Now I'm enabling the ADC enable bit, and in this part I am setting up the sample time. So let me look that up in the reference manual. This is how many samples I'm going to be taking, and I'm using the max. So what I'm doing is I'm putting a 1 in the 0 position, 0 bit, putting a 1 in the 1 bit, and putting a 1 in the 2 bit. So let's go back to the program. The SMP, the sample number of samples it's going to take. Okay, so let's look that up here. It's probably right here somewhere. Yeah, here it is. All right, so the sample bits, this is an entire 32-bit register that only 2 bits or only 3 bits are being used in that register. So I guess it didn't have enough configurations for needing more than this. All right, so, and it's kind of a waste of a whole set of registers, or whole set of bits in a register. I wonder why they couldn't do something like this, like the configuration register number 2. They couldn't have put the sample bits here instead. All right, so the sample bits here are informing the ADC to use a certain number of clock cycles for the ADC to receive samples. So right now I have it set for 239.5 samples. So it's going to collect 239 samples, and I guess it's going to average them out or or maybe get the cleaner samples of them all. Let's see if we can find that out actually, because I'm kind of curious. So whenever I have a question about the samples or anything like this, it's going to tell you in a section in the ADC chapter. All right, ADC SMPR. I don't want to comment. Control C, Control F, Control V. All right, only one. Let's see, ADC or sample. I know there's going to be too many instances, so I'm going to go ahead and look it up in the table of contents. Okay, so it's in the 200, so I can always look at that. All right. Okay, so the sampling time, 190. Let's go ahead and look at that. Before starting a conversion, the ADC needs to establish a direct connection between the voltage source to be measured and the embedded sampling capacitor of the ADC. This sampling time must be enough for the input voltage source to be charged, to charge the sample and hold capacitor to the input voltage level. Okay, so it has to charge up a capacitor, and the capacitor is receiving the charge of the input voltage of the item that we're sensing. So like the x-axis of the accelerometer. So the capacitor is being charged up. It's probably a very fast charging up capacitor. So we need a number of clock cycles for that to happen. Having a programmable sampling time allows the conversion speed to be trimmed according to the input resistance of the input voltage source. Okay, so that we may need to look at the data sheet of the actual accelerometer. The ADC samples, or what I would do probably is just keep bringing that sampling time down until I get something that's non-usable, and then I'll bring it back up. But the programmable sampling time is common to all channels. So each channel uses the same thing. So that means that when you set it at one time, all the channels will use the same number, which is kind of interesting, where I probably want to read on, but if you have a different resistance input on each device, like if you're using multiple devices, like I have an accelerometer in one channel and I have a temperature sensor in another channel, if the resistances are different, the sampling time should be different as well for each channel. So let me read that again. The ADC samples the input voltage for a number of ADC clock cycles that can be modified using the, okay. This programmable sampling time is common to all channels. If required by the application, the software can change and adapt this sampling time between each conversion. Okay, so I could change the sampling times for each conversion. So like if I wanted the sampling time, we can see that it's doing this during the ADC enabled. So the ADC is enabled. I could probably take this, move it to my never-ending loop, put it right before the AD start for the conversion of that specific channel, and set my sampling times. So I can do this separately for each channel. So that answers my question. So I can, let's see, I could probably do something like this. I'll set it up here as just I guess an initialization. So set sampling time for channel 1, and then I will put that here. And then I can do the same thing for channel 2. I have to see if I have to start the or stop the, I have to see what I have to do between the conversions for each channel before I do this. So I have to see that, but I could do this maybe for channel 2 and make these different. So let's continue reading the reference manual. If required by the application, the software can change and adapt the sampling time between conversions. Okay, so the total conversion time is calculated as follows. T conversion equals the sampling time plus 12.5 times the ADC clock cycles. I'd like to know where that number comes from. Okay, so let's see. So the example with the ADC clock is equal to 14 megahertz and the sampling time of 1.5 ADC clock cycles. That would be the minimum, I think, the smallest amount of cycles. The T conversion would be equal to the 1.5 clock cycles plus 12.5, which equals 14 ADC clock cycles. Okay, I see what they're doing here. But I don't know why they have the multiplication here. Equals 1 microsecond. All right, so the ADC indicates the end of the sampling phase by setting the end of sample flag. Okay, that's interesting. So what am I doing here? Okay, I'm not doing anything for the end of cycle. So this is automatically being done probably by the, no, this is end of conversion. So the end of conversion probably takes the end of cycle, end of sampling into consideration. All right, so the ADC indicates the end of sampling time by setting the EOSSMP flag. All right, so a single conversion mode, that's not something I want to look at right now. Continuous conversion mode. All right, so this is constantly, so the single conversion mode is getting one conversion and you're done. So this would be more of a manual approach, I guess. And then continuous would be just constantly scanning the conversions. All right, so let's see what's next here. So now then I'm going to take this out because I don't want to use it yet. I'll probably just keep the same sampling time for each channel, just to make it easy and not make too much complexity yet. So sort of a scaffolding approach. So what I'm doing is I'm starting up the conversion. So this is where it starts the conversion. It is starting to make samples. It's charging up the capacitor in the microcontroller to the level of the input voltage of the sensor. Then this is the interrupt service register. It's looking for the end of conversion flag to be set. So while it's 0, it's still converting. It's hasn't gotten to the end of conversion. So the end of conversion flag, once it's 1, we can go ahead and collect the value of the conversion. So this conversion is located at the data register in ADC1. So I'm using the ADC1, obviously. Let me show you the pinout of that. So on the Newbiehack website, I have the pinout of this microcontroller here. So you can see that it's kind of oriented like this. This is the pin number 1, and this is pin number 30, and then you have 31 through 34 on the bottom, and then 35 to 64. So in this case, I'm going to be using pin number 15 for the x-axis, and then pin number 16 for the y-axis. So we have ADC in 1, ADC in 2, and because it's ADC 1 in 1, I'm using that in the program. Because other microcontrollers have more than one ADC, this particular one has only a single ADC, so it's not specifying 1, 2, or 3. It's just ADC. But in the programming, you still have to put the 1 because this is programming macros. They set up the macros for multiple microcontrollers, so it just makes sense to do ADC 1 just in case you have a microcontroller that has more than one ADC. All right, so this works. I'm going to go ahead and give it a try just to see if I have everything right. I'm going to take this out. So just to have a sanity check on whether this program works, I'll check it out. So what I'm going to do is I'm going to flash the microcontroller using this. I'm not even showing you what I'm showing. Sorry about that. All right. So I have the program. I'm going to flash the microcontroller using this button right here. This is a play button, essentially. So I'm able to, I could put it in debug mode if I wanted to, and it'll go line by line. And that's pretty cool, being able to do that with a microcontroller, because it has to communicate to the microcontroller and then communicate back information. So what it actually, like variable assignments and values and things like that, and you can actually see that while you're debugging. But here I'm just going to run it, and before I do that, I'm going to plug it into my microcontroller. So let me show that. All right, so I'm going to be using the ST-Link V2. And when I plug this into my microcontroller, there is a possibility that my cameras and everything will fail. So I am going to be getting a video mixer pretty soon, so I won't have these issues. So hopefully this will work. I'm taking a standard Amazon or a USB to USB, female to male cable just to connect. All right, is my camera still working? Good. All right, here we go. Hey, Tomas. Welcome. Hello, I've just arrived. I am interested in MCU programming. I've read your book and now learning to dive BLDC motor by Trinamic drivers. That's pretty cool. So what? I'm not familiar with the with those drivers. Those are. How would you control those drivers? In what way? Is it like a PWM type thing, or once I press the play button, this red LED should blink on and off? So let's see if I can get both. No, that's going to be too difficult here. Let me just press the play and then I'll switch over real fast. All right, so I'm going to be pressing the play button, and it is definitely blinking. It's kind of hard to see on camera. And then in the output, you should see this information here: download verified successfully. That's my clue that, and then it says shutting down and exit. That's my clue that it actually did upload successfully to the microcontroller. And you can look through here to see if there's any issues. You can also look into problems and see if there's warnings, or it has warnings, but it's over all of my projects. So, and I don't see any warnings for this particular project. I'm going to go back to my console, and then I know that I have it loaded onto my microcontroller. That is weird. It is not showing the correct. Check that out. Only half of it is showing. Let me oh wait, you know what? That's why. The window is off of my screen. That's funny. All right, still there. Good, good. All right, so I've transferred the program to my microcontroller, and I'm going to disconnect. The program is still going to be on there. Obviously, it's non-volatile memory, and I'm going to plug in the sensor. So let's see, where is that sensor? I didn't want to plug it in while it was on. So let's see. I'm going to go in a little bit closer here so I can see what I'm doing. I can't even see. But I think in camera I might be able to see better. Okay, so 15, 16, and 17 are the locations. The green is the X, the blue is the Y, and the white is the Z. I also have the power that I need to plug in. So the plus rail is over here and the minus is over here. So I have to make sure that the plus, the red, is going to be plugged into the plus rail. That looks right. You can control them via SPI. Okay, cool. The TMC4671 is servo controller. You are manipulating its registers to make it send PWM to gate driver. I just made an SPI video using Claude and ChatGPT. Did you watch that? All right, so now what I'm going to do is I'm going to plug this back in. I'm going to get a better view of just the general area here. Might need to go way out, actually, so you can see more of my desk. So this is just to make a note about the content that I'm making here in live streams. I'm eventually going to be live streaming every day, just on the projects and things that I'm doing. I'm not really sure yet on what day I'm going to be doing CNC stuff and what day I'm going to be doing ARM microcontroller stuff. But I want to keep doing it so I can keep learning and keep on top of what on top of the subject. All right, Tomas, I hope I'm saying your name right. Yes, I've watched the SPI video. I have a question actually. How can I access the extended cut? Do you have it on Patreon? I am really interested in it since I've programmed it with HAL library. You can go to the YouTube join. So if you go to my channel, let me see if I can find it here. for you. So under the, let's go to YouTube. You're going to see the videos that I watch your channel, and there should be a join somewhere. I might not be able to see it because this is my channel, but if you go to the top and you press /join, you can find it that way. So you'll see, this is what you guys will see. There's fledgling engineer, $3.99 a month, true hacker, $9.99 a month, electron wizard, and master apprentice. So I'm going to be doing more with these, but I just don't have enough people in the member area to be able to do live yet, because nobody would join the live. A lot of people in there are probably needing to see a lot of videos that I made member only, because I'm trying to make this a little bit better monetization, a channel that's more monetized. So you can get there by just doing /join when you see the YouTube channel. Hope that helps. I do explain all of the lines of code in the SPI. All right, I do explain all of the lines of the code for the SPI, but they were generated through Claude. Claude did a really good job. I didn't try the 01 ChatGPT yet. I might do that in a later video. Maybe I can do that in my video here, just as a way to fast track multi-channel ADC operation. Thank you, Tomas. I really appreciate that. Okay, yeah. So I might actually use the 01. In fact, let me do that right now. That would be an interesting experiment. So let's see. I have a paid version of ChatGPT, so don't worry about what's on the left-hand side here. All right, so I could use my GPT. Let's see, STM32 F030 reference, but I don't know if I'm using the GPT-01, so I'm not going to do that. So I'll do a new one. So this is the 01 preview, and what I could do is I could bring in my code and ask it to change it to do multi-channel. Let's just see what happens. You can't see what I'm typing, can you? By the way, do you like this format of video? I'm thinking about just doing stuff in my, whatever I'm doing with the CNC or the microcontroller stuff. It's just going to be me, working out projects. Each live stream will probably just have a very small portion of a project done. I don't expect to have it completely done, but at least you can see what goes on in my mind, and if that helps anybody, that would be awesome. Here's the code that I wrote to receive from an accelerometer using the ADC of STM32 F030. My English isn't very good, or my sentence form isn't very good. Accelerometer, the voltage. Here's the code I wrote. Okay, so let me go ahead and put in the code. Wait, I want to say, how would I change it to read multiple channels? All right, let's see what happens. It's so nice to have AI helping us out, but it's still good to know what is being output from the from AI, from ChatGPT or Claude, because if you understand it, you're going to be able to debug it better. Okay, so there's a lot of information here, so let's take a look at it. So to modify your code to read multiple ADC channels on the STM32 F0 blah blah blah, you need to make several changes. Select multiple channels, modify the ADC1 channel select register, which I kind of knew we needed to do. So the channel select register is right here. So this is, I'm setting the channel to be sampled. So this is the sample channel number 1. So I'm guessing I'm going to have to do that to all of them. So here it is. All right. Okay, so select all the channels you want to read. So I'm wondering if do I have to do this inside or outside the loop? So let's figure that out. Enable the scan mode. Okay, the scan mode is one way or the other. So it's either scanning from channel 1 to channel 3 or scanning from channel 3 to channel 1. So you have that control as well. Okay. So enable the scan mode, scan direction, and I'm not sure if I'm doing that here. I'm not. So I'm leaving that as default. So it's going from 1 to 3 or 1 to 1 right at the moment. So read data from each channel. Adjust your code to handle multiple conversions by reading the ADC data register for each channel after each conversion is complete. So let's make some pseudocode. So right here I would start conversion for channel 2, grab the data, start conversion for channel 3, and then grab the data. All right, so let's see how it wants me to do that. And it's good to do this when you're reading through this. You can also use the reference manual to confirm everything, because maybe it doesn't get it right for this particular microcontroller. So it would be good to still verify what's going on. Select multiple channels. So I can just do this. So all I need to do is actually copy this and just apply it right here. So I'm putting a 1 for channel 1, putting a 1 for channel 1 bit, putting a 1 in the channel 2 bit, and putting a 1 in the channel 3 bit. And still, I don't think I think this is a setup. It's a configuration channel select. So it's probably best to keep this out of the constant loop and move this. So I use a program called STM Studio. Let me get this a little down here. STM Studio is a program that allows you to view variables, and that's really all I've done with it. I'm sure you can do a lot more with it, but this is what I use it for. So I'm going to double click this, and this is what the STM Studio looks like. So you have a space for your variables, display variable settings, and then you have the play button, and you can view the variables in a graph like this, which is called the curve. You can also view it as a bar graph, or you can view it as a table. So let's use the curve. This is the one I like to use. And what I do is I press the right button in this section here, and I use the import. So it's asking me to fill in the executable file, which is the ELF file that is created when you press the play button in the STM cube ID. So you can see that there's a binaries outline here, and then there's the ADC 2000G accelerometer ELF file. So I'm going to press the right button. I'm going to go to properties, and right here you can see, if you can't see this part of the properties, just press resource and it'll go to that. So I'm just going to do a copy and paste of the full location, Control C, of that file, because that's what STM Studio needs. So I'm hoping there's going to be an error here, so I can help you out if there is. So I'm going to press the ellipsis here, the ellipsis button, and just paste it. So when I select executable file, you may see some errors. This is one error, but if you see another error, I'm going to show you how to work out that problem. But let me go ahead and this error is not a big deal. I'm not worried about this one. You'll still get the ADC value variable here, and I'm going to import that variable, and I'm going to close. So now you'll see that variable in this location right here. And I need to send this variable to a location, or to the var viewer. You can see that I guess you can put more viewers here, but I haven't done that. So I'm going to send to var viewer 1, and once I plug the microcontroller in, once I plug that in and then I press the play button here, the little LED on the STM link will start blinking, showing that there's communication between the STM Studio and the microcontroller. So let's go ahead and press play, and there's nothing there. So let's, oh, it's because it's outside of the range. So the range The lower value is 0. I'm going to put that as I'm going to keep that at 0 because in the video I had last night uploaded, the value of the X is going to be right in the middle of the 3.3 volts. It's going to be like if you have 0 and you have 3.3 volts, the value is going to start in the middle, and then when you hit it, it'll either go down to 0 or it'll go up to 3.3 volts. So it's how this specific accelerometer output works. So I'm going to keep that at 0, and I'm going to make the upper value 4096, because that would be a 12-bit number. Okay, you can already see there's 2000 at mark 2000. There was already some data there. So I'm going to press play. So let's see. So now you can see the numbers or the values running across the screen. You can see that on the bottom here. And let's see. I don't know if I can put this on both on the camera, and let me turn me off. And let's turn on this camera here. And let me see if I can make this show both, sort of. Okay. So I should be able to get something. All right, let's see if I can move this in a way I can. Well, I can just move the stuff, couldn't I? Oh, you can also see that the LED is blinking. And here is the accelerometer. I'm going to see if I can not destroy my table while I'm doing this. All right, you can see a little bit of move. Did you see it? Yeah, that's good. Let me try a little bit of this should be mounted on something more rigid. You're going to see that it's going to cause ringing internally. The piezoelectric structure in here is going to probably vibrate until it gets down to 0, as you can see there. So you can see that there was ringing. It's kind of like a transient response. So a transient response is like this. It starts big, and then it finally settles. That's also called ringing. And if you have this on a mounted on a good substrate, you'll be able to get a better response. So that worked. Let's go ahead and stop. I'm going to get out of the studio. I could save this configuration, but I'm not going to. It's so easy to. But let me show you what happens if you have a problem. And in the you may get I think it's dwarf. Let me see. Let me go to properties here. Okay, so in the build, in the C++ build, and in the settings, in the assembler, the compiler, and linker, you can change some of the command line attributes, functions. So in the miscellaneous, you might want the gdwarf-4 here. If you don't have this, it tries to automatically use the number 5, which the STM Studio is not compatible with. All right, so but you need that flag on all of for the assembler, compiler, and linker. So make sure you have that if you have that error. All right, so let me go back to the other view. All right, so let's get back into the programming here. Okay, so we were evaluating ChatGPT 01 and seeing if that made any sense and see if it got it right. So let's take a look. So we've adjusted the channels and enable scan mode, and the scan direction, I don't think I really need to do this because it's always going to scan in one direction. It's going to go from 1 to 2, 2 to 3, and then go back to 1. And it depends on how many. So if you have 3 channels set up, it'll start with 1, then it'll go to 2, it'll create the samples for 1, and then give you the output or give you the data. Do the samples for number 2 and then give you the data, and do the samples for number 3 and then give you the data. So you can see in the program, you're starting the ADC, and then the conversion is ended, and then you get to grab the information. So when you're doing 3, you can imagine your sampling time is going to multiply by that number of conversions. So if your sampling time is 239 samples or clock cycles, you can imagine doing 3 of them is going to multiply that by 3. So it would be 700 or so clock cycles, something like that. Yeah, somewhere around there. Yeah, around 700 cycles. All right, so enable the scan mode, done that. Or not doing that because I don't really need to. Adjust the while loop. Actually, let me take a look at that in the data sheet. Oh, this is actually kind of important. So in the data register, data alignment is crucially important if you're doing multiple bit sizes, like if you're doing 12-bit conversions, or you're doing 10-bit conversions, or you're doing 8-bit conversions. And I'm going to leave 6-bit conversions out of it because this is an odd one and it doesn't align the data. So if you're doing a 12-bit conversion and you want to switch over to if you're only able to capture 10 bits, I'll get that camera later. You can have it aligned to the left. So a 12-bit number, you can get the 4096. But if you do the 10-bit number, you're still going to get 0 to 4096, but it won't be as precise. The precision will change. So by left aligning it, you're keeping the same numbers from 0 to 4000 whatever, 4096, but you're just skipping a lot of digits in between. But if you have it right aligned, this will be 0 to 4096. This one right here will be 0 to 1028, is it? I think. This one will be 0 to 250. What register is that anyway? That is the CF, the configuration register number 1. Okay, here we go. So this is CFG, that's the ISR. This is the one with the end of conversion. The EOS is, what is the EOS? End of sequence. Okay, that's interesting. You could use that if you need it. All right, let's go to the CFG. This is the main control register. You have the enable, that's the one you're going to generally use, and the AD start to start the conversion. It would have been convenient if the EOC was in this directory or in this register. All right, the CFGR1, here it is, scan direction. So let's take a look at that. Okay, so the scan direction, it's an upward scan from 0 to 17. So at default, it's going to scan from 0 to 1, from 1 to 2 to 2 to 3. But I'm not using 0, so I'm only using 1, 2, and 3. So it'll scan from scan 1, then 2, and then 3. All right. So that's the order it will do the conversions. Okay, so we don't need that, so it's already good. Adjust the while loop to read multiple channels. Okay, so it wants to put it into an array. I don't know if I want to put it into array. I would rather separate them out. So let's see how it's doing the arrays, and then I can write it in a way that it's doing it one at a time instead of this for loop. This is a for loop, and it's doing it from channel index 0 to 3, and it's incrementing it on each loop. So all you're doing is you're not doing anything different. That's interesting. All right, so what we can do here, let me look at that again. So we don't have to start it every single time. So it starts it, and then all it's doing is it's waiting for its end of conversion, and then we can grab the data. Waiting for the end of conversion, grab the data. Waiting for the end of conversion, and then grabbing the data. So let's go ahead and just do that. So I'm going to, and it's doing the start for each one. So it still does the start in the never-ending loop. So it still starts it every time. So I'm hoping this is correct, because, you know, if it isn't, then it won't be good. So let's go ahead and just do a copy and paste, and do another copy and paste. And then what I'll do is I'll change these variables to represent what it's collecting. So Y and Z. Okay. All right, so let's go up here and create those global variables. Okay, so we have the ADC X value, ADC Y value. When I select it, does it? Yeah. And ADC Z value. Yep. Okay. So that works. Okay, so now we can, let's see what else it said. All right, that's it. I didn't need to do anything else. So let's see if it works. That was a very simple change. So I should be able to get X, Y, and a Z response from this accelerometer. So I'm going to change my display here. Okay, let's move this, make it a little bit wider. No, I want to put both on at the same time, don't I? Yeah, let me put the, let's go ahead and flash the microcontroller. Hopefully we won't get any errors. Let me see if I can show all of this screen. Okay, so when I press the play button, it should download to the microcontroller. Okay, it worked. Yay. It's a butt-clenching moment. All right, so now I'm going to start STM Studio. Is this still working? Yeah. So now we should have two more variables appear when I do an import. So let's import the ELF file. Let's see if I go, no, I'm going to do it the easier way. Let's go back here and grab the ELF file. It could be still in my clipboard resource. All right, this is the location. Control C, copy, and Control V for paste. Select. Don't worry about this error. I don't actually know what this means. Does anybody know what this means? All right, so we can see that we have an X value, a Y value, and a Z value. So let's go ahead and I'm going to use the Shift key. Let's see if that works. Yeah, I'm going to import all three of those. Close. So let's put all of them on. You can see that there's different colors for each. There's a blue, a French gray, and a purple. Don't ask me why I know French gray. So we'll put that one on. Let's also change the value to 4000. Let's put this one on var viewer 1 as well, and put this one on var viewer 1 as well. So we have all of them on the var viewer 1. If I press play, it will start to make this blink, and you can see that all three of them are on the display. So let's see if I can get something on this. Nothing. All right, I'm not getting anything. So did I do something wrong in the program? Let's see if the Z will work. I'm not going to be able to do a Z. No, that's going to be too hard. All right, I'm not getting anything. So, but I am getting a 2000. I'm getting it at 2000, which tells me that it's still reading it. So let's see if we did something wrong. It could be I'm just not hitting it hard enough. Who believes that I'm not hitting it hard enough, and who believes I have something wrong in the program? Let's see. 1 would be I'm not hitting it hard enough, and 2 would be the program is at fault. Wrong code. Let's see here. Well, let's take a look. So you think it's wrong code. Okay. Interesting. Yeah, I'll check the code. All right. Let's see here. So I got the start. This is not going to change. We are passing it, so the end of conversion is happening. We are getting from one to the other because we do see that data output. This shouldn't change. What did ChatGPT say about this? Here, let's see. It's still the same. ADC1 DR. I'm setting it to 0, which means that it is definitely converting, because it would be 0 if it wasn't converting correctly. Should I be starting it every single time in the while loop? All right, let's see. I personally think it's correct. The code is correct. We could do a debug session. Hopefully I can remember how to do this. Yeah, that's only because I was, I need to hit it really hard. I think that's going to be what I'm going to do. CNC said hit it harder. Tomas, you have hit it similarly earlier and it worked. Yeah, you're right. But you know, it could be also the amount of time I'm how many samples. It could be the number of samples, but I got ringing last time, so it should get something. Put ground on input. That's a good thing to try. Let me do that. I'm going to put ground on input, but I'm going to disconnect it first. Actually, no, I want to stop how do I stop it? Stop. There. I'm glad I'm getting some feedback from you guys. I like that. All right. I'm disconnecting it. I'm going to take a short piece of wire, and I'll put it on ground. Let's see, where am I? A piece of wire. Let's see if I have anything here. All right, I'm going to take ground and I'm going to hit it to number. Well, you know, this would be floating if I don't put it into anything. What do you think the value would be if it was floating? That would be an interesting thing to learn. Let's see what the value would be just not having anything input. It should be 0, or it could be 3.3 volts. All right, that's still working. Okay. All right, so let's see what happens. I should just keep this out open. I probably still have it in my clipboard. Let's go ahead and try that. Yes, import and then close. So let's put that back in the var viewer. This time I'm gonna save the configuration so I don't have to keep doing this. I don't want to have you guys have to wait for me to do that. Okay, so let's go ahead and play it. Okay, look at that. Because it's a floating value and it's still at 2000, which is interesting. Why is it 2000? Why is it located at 2000? I mean, it's a floating. Oh, look at that. It went to 0. I put my finger close to it. What will happen? Nothing. Okay, let's take a wire and let's connect it to channel 1 for 3.3 volts, and then channel 2 for 3.3 volts, and then channel 3 for 3.3 volts. That should tell us whether this is working or not. What do you think? Did it die? You think it died? All right, let's take a relatively long. We could actually just create an antenna too, just sticking it up in the air and see what we get. That would be kind of a fun. All right, this should be channel 1. All right, so got nothing. I don't have any motors or anything kind of running right now anyway, so it wouldn't do anything. So hopefully I'm not going to get an issue here, although I have a whole bunch of. So let's see, 3, 2, 1, nothing. Okay, so it's not converting. It started good though. Let me stop. See how it starts like that? Okay, I got it to work. So something happened where it just kind of failed over time. So let me change the upper value to 5000. So I'm going to go to 3.3 volts. It's interesting that channel 2 and channel 3 are also increasing. Now I'm going to go to 0 volts. Now it goes to 0. So it is converting. I'm just not hitting it hard enough. So let's go to channel 2. Okay, so channel 2, which is the French gray, is running at 4096. I took it out, but I'm still curious why the other ones are now more or less noisy, I should say. Let's go to 0 here, 0 volts. Okay, so that worked. So the pull rate is once every 700 clock cycles. I can increase that. Let's try increasing. You see how everything got really crazy there? It's because when you have something floating, you're going to get atmospheric noise, EMI, whatever. Okay, so they're all working. They're all converting correctly. So I'm going to go ahead and stop, unplug it. I'm not going to get out of this, so I can just go right back into it if I have to. So it is working. I just need to hit it harder, I think. What do you guys think? I'm thinking the program is good. So the pull rate, let me go over that. Let's change that actually. So this is the sample rate. So for every 239.5 clock cycles, it is picking up samples. So if I increase that, or if I decrease that, it will make it a faster. Let's go back to the reference manual. If I make it faster or make it fewer cycles for sampling, then let me make this smaller. So I should get more samples per, or less samples, but more conversions. So which one is that? That's in the SMPR register. Did I pass it? Yep, here it is. Okay, so we have these clock cycles that we can use. So let's go to the fewest clock cycles. Accelerometer is a pretty fast accelerometer. I think it's 10,000 hertz. So CNC is asking, so to change your pull rate, is that in your for loop, or use a different clock. No, you're using the same clock. You're just changing the number of cycles it. Because when you're collecting data from an ADC or voltage source, the microcontroller needs to charge its internal capacitor it needs enough time to charge that capacitor to the voltage that is being input. So what it's saying in the reference manual is that there may be a resistance in the device that you're using, so that could increase the amount of time that the capacitor charges up to the voltage level of the output of the sensor. So we need this to be high enough that it will be able to charge the capacitor up to that amount of the input of the voltage. So let's make it the fastest possible. Let's just see what happens. I'm kind of curious. Anyway. All right, so to change that, it would be 0, 0, and 0. So right now I have it 1, 1, and 1. So let's make it 0, 0, 0. I'm going to make this in 3 different lines because I can't remember how to do it in one line. It's probably like this, actually. I'm thinking it's like this, not, and then an and here, and then a not, and then an and here, and not. But to confirm, I'd like to put it on 3 separate lines, so I'm going to do that. Okay, CNC, I'm probably going to be gone by that time, but it was nice for you to come by. I appreciate it. Okay, so I'm going to take this one and get rid of this, and then get rid of all these here. So this is making sure to put 0, 1, and 2 to 0. So let's go ahead and save that, and I'm going to go ahead and flash the microcontroller again. If it doesn't flash properly, it could be just the connections between these two, or you're not getting power or something. Well, let me, okay. Nobody on Twitch still. Nobody likes me on Twitch. I wonder if Twitch is actually working. I'm so inexperienced on Twitch. It says live and it says excellent, so that's good. There is one viewer though. So if you're a viewer on Twitch, let me know. Say hello. All right. So I'm going to go ahead and flash using the little play button here. And we'll see this blink. Yep, it's blinking. And then shutting down. Download verified successfully. So that's good. That worked. All right, so let's go back to the STM Studio. Well, I've got 2 versions working. That might be the problem. I had 2 of these open at the same time. I wonder if that was the problem. All right, so let's go ahead and press play. Yes, good. Okay, so let's try this again. Nothing. Let me take out... I want to try to go back to the way I was doing it, because it really should work, unless I broke the accelerometer. And it could be also the sampling time too. So let's go back. I'm going to keep the sampling time at 0, and I'm going to remove these 2. I'm just going to comment these out to see if I can get back to, no, not this. What am I doing? To get back to the way I was doing it before, or a working version of it. And then maybe I can just open up the second one and see if that one works. Oh, look at this. I have 2 semicolons. I don't think that would have been the problem though. Let me do this instead. Okay, so I only have channel 1. Let's save it, transfer it, download verified. Okay, so now this is going to change. So I want to, actually these 2 should show as 0 or give an error. Let's see. I've never tried this. Yeah, see, only the 1 is showing up. So if I try to make it work, that's weird. It's still not working. All right, let me stop it. I'm gonna redo the ELF just to make sure. Oh, you know what? Yeah, because I have it initialized. I'm gonna delete these. There we go. It worked there. All right, so let me add one more. Yes, the STM Studio is free. This is Skeptic. Yeah, probably more interested in games over there. Tomas. Tomas, yes it is. Okay, yeah, you're answering Skeptic. Isn't it nice to have a small community? I can look at all the comments. It's 1 plus. That's the 1 plus about that. Okay. So now I'm gonna go and just do one more channel, You can hear my son in the background. He's outside talking very loud. All right, so I'm gonna let this one out. So let's go ahead and do another transfer. Are there any problems in this? I don't see, yeah, there's no exclamation marks. Okay, so it's transferred. Download verified successfully. All right, so now I'm going to import again. Let's take this one, import it. This is the Y value, and close. So let's play. I'm not sending this to the VAR viewer, so let me do that. Let me stop it and then start it again. I don't think it did that. Okay, good. I don't see it. Oh, it's on the bottom. It says 0. That's not right. So that's definitely not working. Let's see why. Oh, wait. No, this is good. I'm not using this. Not that it really matters. I'm going to go and put this back to the longest time. I just want to ensure that it's working. Right, so channel 1, channel 2. I'm starting. End of conversion for channel 1. End of conversion for channel 2. Let's do that again. 0 errors. All right. So let's go back to STM Studio. Yeah, all the software that STMicro puts out there is free. There's also a monitor program that's really good too. STM Cube Monitor, I think it's called. And you can actually create dashboards and stuff. It's really nice. All right, so let's see if this works. Okay, I've got both of them on there now. That's nice to see. And still I got nothing. So there's something going on with the multi-channel operation of this. So I'm going to leave it there until I'll probably log on Monday and continue this project because I have to go to the pool with my wife. So I hope you guys enjoy